HCV's doubts will take 10-15 minutes. We'll solve it either in today's classes or the next class. In the last half an hour, we'll finish it. Don't worry. First of all, we deal with calculus-based problems, variable force.
Only one sum. 23.
Pulley. Okay. I'll merge it up with friction. Just remind me once. Friction is an intelligent force. Friction is not like tension and normal force. Tension and normal force were docile. They followed certain standard rules. You will have to follow the rules of friction. That's the problem with friction. Actually, laws of motion and friction are not two separate chapters. They are the same. HCV, for our convenience, split it into two. We have kept both in the same booklet. Firstly, friction opposes relative motion between two surfaces. Friction opposes relative motion between two surfaces. Second, they have experimentally found friction to be directly proportional to the normal force. This was purely experimental observation. They have experimentally observed friction to be directly proportional to the normal force. Right? Proportionality, once they removed, this is mu n. Once they remove the proportionality, this will be mu n. Right? What is this mu called as? Coefficient of friction. Generally, for practical reasons, mu will be less than 1, greater than 0. For practical reasons, are you trying to tell me that theoretically mu can even be greater than 1? Not just theoretically, even for practical situations, there can be situations where mu is greater than 1. Over polished surfaces, Fevicol, adhesives, mu will be greater than 1. We will deal with those situations separately. Right now we will deal with situations where mu is less than 1, greater than 0.
Why will the mu 1 greater than 1 for that?
We will deal with those situations separately. Right? Here mu is less than 1, greater than 0, and it is a dimensionless quantity. No units, because F is also force, normal force is also force. Right? Mu is defined as the coefficient of friction, ratio of frictional force to normal force. Second most important thing here, till now whenever I use the word normal force, I was having the liberty of using this word with not much of a discretion. I can call it contact force, I can call it normal force, I can call it normal contact force, so on. Not anymore. Now if there is friction here, resultant will be contact force. R will be root over of n square plus f square. Till now I was having a smooth surface, there was no friction. If there was no friction, then normal force can be also referred to as contact force. R and n were the same. But once I have got friction, contact force, R will be contact force, also referred to as normal contact force. Right? Phi will be, tan phi will be F by n, where phi is called angle of contact or contact angle. Phi will be called as angle of contact or contact angle. Hereafter, be very clear about what you are referring to. Is it normal force or contact force? They are two different things. Till now you had the liberty of using both with not much of a discretion because there was no friction. So n was equal to R. Fine. This F equal to mu n technically is called as the limiting value. limiting value implies this is the maximum value of friction that can act on the surface. How, why and what does this limiting value mean will be explained. I need the board. Now listen, what did you mean by the limiting value of friction? You told me frictional force is mu m. You are calling it the limiting value. That means if you have m here, the normal force is this mg. The frictional force acting on this block is mu n. This will be mu mg. This is the limiting value. That means actually friction acting on this block will be less than mu mg, greater than 0. Say, let me keep it as mu n. This is the maximum value of friction, minimum value of friction acting. Friction can take any value between 0 to mu n. It's an intelligent force. Its purpose is to oppose relative motion between two surfaces. What does that mean? I will take a numerical example. Observe this carefully. Suppose this is m and mu mg turned out to be 10 Newton. Mass and mu are so adjusted that you got mu mg to be 10 Newton. So what is the limiting friction acting on it? 10 Newton. This is the maximum value of friction acting on it. Implies if I apply a force of external force of 5 Newton, what is the value of friction acting?
5.
It's not 10. Because when I push a block this way, the block will not accelerate in the backward direction. So the block is at rest. The block is at rest. If there is 5 Newton of a force, frictional force should be 5 Newton. What if I apply 8 Newton? What will be the frictional force?
8 Newton.
What if I apply 10 Newton?
10.
Frictional force will be 10 Newton. What if I apply 12 Newton? Frictional force will remain at 10 Newton. Now this body is accelerating. 12 minus 10 by m meters per second square. This is what we mean by limiting value. Butane it, if I reverse the direction of this particular force, F external, friction will act in the backward direction equal to the external force or equal to 10 Newton. But if I tell you the block is moving, the block is sliding, then 100% frictional force is limiting value. 100% frictional force is limiting value. Are you clear with that? All of you? Quick.
According to tan phi will be equal to mu.
Pardon?
Tan phi will be equal to mu.
Shh.
Tan phi will be equal to mu.
10 5. Tan 5 will not be equal to mu unless until the body is sliding. I will come to that.
Sir, you said that friction can be is limited to a fixed value. So and also that when there is any movement, it's usually an external force. So suppose a man is walking on the surface with a maximum friction of 10, and using his feet he pushes the he applies a force of 12 newtons. So will he be moving ahead with a force of 12 newtons or 10 newtons?
See, if the limiting friction between the feet and the ground is 10 Newton, man cannot push the ground with 12 Newton. The maximum he can apply is 10 Newton only. If he wants to further increase the limiting friction, either he will have to increase his normal force, that is his weight, or he will have to increase mu by using spikes.
Okay.
Mu will depend on the nature of the surface. So that's the reason why they use spikes to walk on ice. So that mu will be greater.
Okay. हाँ sir, समझा sir.
So what is the logic behind using spikes?
Mu will increase. Mu will depend purely on the nature of the surface. Now before we go into the details, if you take a fine polished glass plate, and place it under a scanning electron micrograph, SEM, you will get the molecular structure of the surface. These are the two surfaces. Halliday Resnick has given a photograph of this. This surface, when you see with a naked eye, will appear fine polished surface. The same surface, when you put it under a scanning electron micrograph, it is this what you see. Now why does friction come into the picture? It is the restoring force between these. When you are pulling this block to the left, there will be compression, elastic nature of this. This will start applying a force, and hence there will be frictional force acting in the backward direction. Opposes motion because of the interlocking of the surfaces. You will never ever have a perfectly polished plane surface. What appears to your naked eye as perfectly polished plane surface will actually be a surface like this. When you place it under a scanning electron microscope, you will see the photograph this way. The photograph of this is given in Halliday Resnick. You can have a look. This is the root cause for mu, coefficient of friction. Hence there is an approximation. All the problems that you deal with, the velocity should be less than 20 meters per second, because if this body is moving at very high velocities, then these peaks will get chopped off. When the peaks get chopped off, mu will change. Hence, what we are dealing with has a limiting value. In fact, HCV says it will be more appropriate to consider the velocity less than 10 meters per second. We will not bother about it. In some problems, we will even reach 100 meters per second, yet we will use the same theory. But for practical reasons, the velocity should be comparable to 10 meters per second. If not, these peaks get chopped off and the value of mu will change. For us, in the problems, value of mu remains constant. Clear with the logic? Now, second point here is, when you said contact angle, only if the body is moving, this is N, this is friction, this is R, this is phi. If the body is moving, rather right word is sliding, then frictional force is mu n. If the body is not moving, frictional force can be any value between 0 to mu n. Right? Frictional force can be any value between 0 to mu n. Now once the body is moving, tan phi will be mu n upon n. This will be mu. Tan phi will be equal to mu only if the body is sliding. If the body is not sliding, then frictional force is less than mu n. Tan phi is equal to frictional force by n. This will be less than mu. Tan phi will be less than this particular value because frictional force is less than mu n. So tan phi will be less than mu. Do not assume tan phi always to be equal to mu. That happens only if the block is sliding. If the block is not sliding, frictional force will be less than mu n. So tan phi will be less than mu. Look at this. When you draw the graph for friction,
Sir, the body is moving on rough surface, then extra friction will be applied.
Rough surface पर mu ज़्यादा होगा ना यार. Mu will define the nature of the surface. Smooth surface का mu कम होगा, rough surface का mu ज़्यादा होगा. So as it is, friction will be large on a rough surface.
Thank you, sir.
Okay, listen. Now suppose there is an external force on a block. Till I reach a particular value, external force will be equal to the frictional force. That angle is 45 degrees because both of them are equal. Listen,
Sir,
if this is an external force,
sir, in the case if a body is not sliding but rolling, is the coefficient
sliding
of
friction हुआ नहीं यार अभी तक rolling कहाँ जा रहे हो rotational dynamics 4 chapters wait करना है रुको. Listen, F external is equal to frictional force. As and when you are applying this, F external will be equal to the frictional force. Agreed? As and when you are applying the force, F external will be equal to the frictional force. The moment you reach the limiting value, this will be mu n. The moment you reach the limiting value, friction will remain constant thereafter, even if you are increasing the external force. Even if you are increasing the external force, mu n will remain the same. This is what you told me till now. Yes or no? There is a small correction here. What is the correction? This will take a small plunge this way and it will become a straight line. This value will be mu s into n. This value will be mu k into n. What is this? Mu s is coefficient of static friction. Mu k is coefficient of kinetic friction. What is the difference between the two? You told me when there is interlocking between the surfaces, initially this interlocking of the surfaces will be stable. These peaks will sit into the other peak. For you initially to make it start, I will have to apply slightly greater force. Once it starts moving, this will rise. So then it will be mu k into n. To lift this from the grooves that it is sitting in, I need to apply slightly greater force. Hence this will be mu s into n. Once it starts moving, there will be small bending of these peaks. The coefficient of friction will slightly decrease. But in problems you never give me two different values. You always give me mu to be the same. The values will be this way. Mu s is 0.16. 0.36. Mu k will be 0.35. Or say this is 4, this is 1. Now generally we will not give you these both values separately. We will give you mu as 0.3 because we are not going up to the second decimal place. But if you are going up to the second decimal place, you are supposed to differentiate between the two. There will be a slight difference between static and kinetic friction. When the body is moving, limiting value of friction is mu k into n. To make the body move, the force that I need to apply is mu s into n. If the block is at rest, to make it move, the value of the force that I should apply is mu s into n. Suppose the block started moving. To make it move with uniform speed, what is the force I should apply? Mu k into n. Is the logic clear? The difference is mainly because of the interlocking of the grooves between the two surfaces. For us, for practical reasons, we will not give you the second decimal place. We will give you only first decimal place, so it makes no difference for us when it comes to static and kinetic friction. Sometimes in the problems they will play. They will tell you block is at rest. Mu s is so much, mu k is so much. What is the force I should apply to make it move? Then it will be mu s into n. Say that again.
So अगर वो already चल रहा होगा तो सिर्फ mu k
So mu k.
तो mu s को consideration में नहीं लेना.
Once it is moving, it is mu k into n. See, it goes till here, slightly decreases and comes over here. This will be mu s into n. This will be mu k into n. The peak value will be mu s into n. This is the frictional force for which the body just started moving. Till then, the block was at rest. This angle is 45 degree. At this value, the body just started moving, that is mu s into n. Once after it moves, the mu value will slightly decrease in the second decimal plane. So it will be mu k.
Sir,
Yeah.
sir, in the case where body is not sliding but the external force is just equal to mu n, so tan phi will be less than or equal to mu, right? So because of that.
If the body is not sliding and the force applied is equal to mu n, it is the limiting value. So frictional force is also be mu n.
Yes. So then tan phi is equal to mu, right?
Tan phi is equal to mu at that limiting value. Yes.
Yeah. So for generally when we say that the body is not sliding, it will be tan phi is less than or equal to mu, or is it only less than mu?
When the body is not sliding, it is less than mu, no yaar. Just about to slide, it is equal to mu.
Oh. Okay, yeah. Thank you, sir.
So the decrease in the graph, as in from USN to UKN, what does that indicate?
Once it starts moving, the interlocking will slightly rupture. So mu value will decrease in the second decimal place. Not sliding. Two things you will have to consider. Firstly, is there an external force? If there is no external force, frictional force acting is zero. Now as and when I apply, for it to just start moving, the force I should apply is mu s into n. Once it starts sliding, to make it move with uniform speed, what is the force I should apply? Mu k into n. Clear up the board. Now listen. Body down and inclined. Motion of a body sliding down and inclined. This is small m, this is capital M, and this is fixed. See the way you resolve the forces. This will be mg. Whenever I resolve a vector adjacent to the angle, it is vector into cos theta. Not adjacent to the angle will be vector into sin theta. Frictional force is mu n. Component of weight adjacent to the angle vector into cos theta. Not adjacent to the angle vector into sin theta. Right? Now frictional force is mu n. N is not mg here. N is not mg. What is n equal to? Mg cos theta. Perpendicular to the inclined plane, it is not moving. So what will be the acceleration of a body down the inclined plane? Mg sin theta minus mu mg cos theta. This is hey. I will write the next step again. A is equal to divide by the mass, I get the acceleration. Mg sin theta is the force minus mu mg cos theta, mu n is mg cos theta. Divide by mass, this is the acceleration with which a body is sliding down an inclined plane. Because friction is mu n, this is mu mg cos theta. Clear? Sure? Quick? What's the maximum value of friction? Body sliding down. If the body is sliding, always the value of friction is mu n. If the body is not sliding, value of friction is external force acting on it. Let me take a numerical example. Please pay attention here. Theta, I have taken mg sin theta to be 10 Newton. I have adjusted the numbers of mg sin theta such that it is 10 Newton, and mu n ka value I have adjusted as 5 Newton. Will the block slide down the inclined plane? Will the block slide down the inclined plane? Hey, theory काहे को देख रहे हो यार? mg sin theta is 10, mu n is 5. Will the block slide down the inclined plane?
Yes, sir.
Confident? How confident are you about the fact that the block will slide down? 100%, 90%, 80%? 100%?
Yes, sir.
Sure. Wonderful. Now, same person. If I apply an external force of 5 Newton, will the block be at rest?
No.
I said same person. Why are you people are in a hurry? If I apply a force of 5 Newton, for sure the block will be at rest. Your friends are ditching you. Right? Listen. First of all, I kept the block on the inclined plane. I know the value of mg sin theta and mu n, and hence when I kept the block, I applied a force of 5 Newton above. The block will remain at
Yes.
Everybody clear with this, or anybody has a doubt?
Sir, won't there be a friction?
So it won't move with a constant velocity.
Newton doesn't differentiate between constant velocity and rest. For us, both the states are the same. I don't mind. If the block was sliding and I applied a 5 Newton, then it will move with constant velocity. If I kept the block and simultaneously applied F external, then the block will be at rest. For me, both the states are the same. Clear?
Can we see that it just started to move?
Just at rest, limiting condition. Rest or just moving are the same. Relax. Now, think carefully, concentrate. I increased the force applied to 7 Newton. Let's give a chance to Nerul. Switch on the mic. Now answer this question. From 5 Newton, I increased it to 7 Newton. What will be the acceleration of this block? Nerul, please speak. Will the block accelerate upwards or downwards? Now listen to me carefully. Limiting value of friction is 5 Newton. Friction is intelligent and very loyal to the surface on which it acts. It decreases its value to 2 Newton, 3 Newton to make sure that the block is at rest. 10 Newton will be balanced by these both. Friction can be any value between 0 to mu n. Now we decide to make the external force 10 Newton.
सर नहीं समझा सर वो 3 न्यूटन क्यों हुआ?
External force is 7 Newton. Friction will decrease its value to 3 to make sure this is 10, and it is balancing it to keep the block at rest with respect to the wedge. Friction can take any value lesser than mu n, greater than 0. Smart force, right? Now listen. Now if the external force becomes 10 Newton, 0. Friction doesn't have any ego problem in decreasing its value to 0 to make sure that the block is at rest with respect to the surface. Right? Look at the loyalty with which friction will act. Now suppose I have made it 12 Newton. Friction will change its direction and act as 2 Newton to make sure that the block is at rest. Now make it 15 Newton. Friction will raise to 5 Newton to keep the block at rest. Beyond which friction is helpless. I make it beyond 15 Newton anything, the block will start accelerating upwards. The maximum that friction can help me is with this 5 Newton. It doesn't mind bringing its value to 0. It doesn't mind acting in the opposite direction. It will make every possible attempt to keep the block at rest. Awesome, right?
Yes, sir.
Quick.
सर तो 7 और 3 के कॉम्बिनेशन में रेस्ट पे आएगा तो
पूरा रेस्ट में रहेगा 5 से 15 तक 5 से 15 तक this block will be at rest. Friction will keep adjusting its value, right? Sure, take it down and again explain.
सर आपने बोली कि अगर 5 न्यूटन अगर एक्सटर्नल अप्लाई करें तो उसका फ्रिक्शन नहीं एक्ट होगा।
फ्रिक्शन 0 हो जाएगा।
Listen, I don't want noise in this room.
सर अगर आप एक्सटर्नल फोर्स लगा रहे हो 5 न्यूटन तो उसका भी फ्रिक्शन ऑपोजिट डायरेक्शन में एक्ट होना चाहिए ना।
उसका भी फ्रिक्शन मतलब 5 Newton. I am pulling with 5 Newton upwards. So reaction of this will be on the man who is applying it. Why do I care about it? I have drawn the free body diagram for a small m. If there is some external force, you mean to say reaction of this? Man who is applying 5 Newton will experience the reaction. Action and reaction will never be on the same body.
So तो उसको inclined plane पे क्यों नहीं reaction होता?
इसका external force inclined plane पर थोड़ी apply किया है, mass पर apply किया है. So reaction will be on the man who is applying it. I push a block, block will push me, right? Somebody is pulling this mass, mass will pull that man. I didn't draw the free body diagram of that man.
So earlier cases when we applied F external, there was a friction which was equal to that force.
Even here there is. When I applied F external 5 Newton, friction correspondingly adjusted to 5 Newton. When I made it 7 Newton, friction adjusted to 3 Newton. Friction does everything possible to keep the block at rest. Now when there are only two forces, F external and friction, then they will be equal. Here I have got mg sin theta along with it. Right? I repeat the logic, please pay attention. I have numerically taken a value of mg sin theta as 10 and maximum limiting friction as 5. Now, if I apply an external force of 5, the block will be at rest because 10 is equal to 5 plus 5. If I increase my external force to 7 Newton, the block will not immediately start moving. Friction will decrease to 3 Newton so that the sum remains at 10. Right? If I further increase the force to 10 Newton, friction will decrease to 0 to make sure that the block is at rest. Because 10 plus 0 should be equal to 10. If I further increase to 12 Newton, block will not accelerate. Friction will act downwards with 2 Newton. So that 12 Newton will be equal to 10 plus 2. If I further increase to 15 Newton, friction here will raise to 5 Newton. System will yet remain at rest. If I cross 15 Newton, then the block will start sliding upwards. Is this clear to all? Let me put the same thing in terms of symbols. Here I have taken a numerical example. Suppose I put it as symbol F maximum and minimum to keep the block at rest. This is small m. This will be F minimum when I have mu n acting this way and this is mg sin theta. This is mg cos theta. This is n. F minimum plus mu n will be equal to mg sin theta. This is minimum force, right? F minimum plus mu mg cos theta is mg sin theta. Contrary to this, if I take the block and F maximum, now because of F maximum the block has a tendency to slide in the upward direction. This is mg sin theta, this is mu mg cos theta, because this will be mg cos theta, this will be n. Now as I am increasing the force, the body will have a tendency to slide in the upward direction. Friction will act in downward direction. When I take the maximum value of friction mu n, this will be F maximum. So F maximum will be mg sin theta plus mu mg cos theta. Here F minimum will be mg sin theta minus mu mg cos theta. Is that clear? Yes. When I am applying minimum force, this block had a tendency to slide downwards. Friction maximum value was acting upwards. As I start increasing this force, the body tendency to move will be in the upward direction. Friction will act in downward direction. Quick. F maximum and minimum to keep the block at rest. To keep small m at
Sir,
yeah.
so can we say that if the force applied on the block will be greater than the mg sin theta, then the friction will be acting opposite to that force. But if it is less than mg sin theta, then it will be acting opposite to mg sin theta.
Why do you want to do that? Is there any benefit in it? Look at it the way it is told. There is a benefit in this, right? See, mg sin theta, is it greater than the friction? Yes, when the block is sliding. When it has a tendency to slip in the downward direction, I should apply a force in the upward direction. As I increase this force, there will be a tendency to slip in the upward direction. So friction will act in downward direction. Simple.
Okay, sir. Thank you, sir.
Angle is 37 degree. 5 kg block. Mu is 0.4. Say make it 0.5. What is the value of friction acting on the 5 kg block? Find the value of friction acting on the 5 kg block. Find frictional force acting on 5 kg block. How much is this? Mu mg cos 37. 0.5 into 5 into 10 into cos 37 is 4 by 5. 20 Newton.
Is 2 meters.
Agreed? What if 5 kg block, 37 degree, right? Mu is 0.8. Find the value of friction acting on the 5 kg block.
Sir, 30.
नहीं सर, तो 30 तो नीचे ही लग रहा है, 32 लगेगा तो फिर
30 30 30 is acting down.
Sir, 32 Newton.
Intelligent force.
Intelligence. Sir, 32 Newton.
30. So 30.
30.
30. So 30. 5 kg will normally.
Listen. What is the value of mu mg cos 37 in this case? 32. What is the value of mg sin theta in this case? 30 Newton. So will the block move?
No.
If the block is not moving, what will be the value of friction? 30. Friction will decrease its value to make sure that it is at rest. So frictional force acting here is mg sin theta, which will be 30 Newton. Is the point clear to all? Then here, why did you tell me mu mg cos theta? Because I am damn sure that this is sliding. Mg sin theta is 30 Newton. 30 Newton is greater than 20. Once the block is sliding, I know frictional force is mu n. If the block is not sliding, frictional force is equal to the external force acting on it. What is the external force? Mg sin theta. Now listen. Angle of the incline at which small m starts sliding, obviously sliding down. Suppose I keep a block this way and I keep the duster on it. As I start increasing the angle at some state, the duster will start sliding. Right? That angle at which the body starts sliding is called at what angle? This will angle of repose. This will be called angle of repose. mg sin theta should be equal to mu mg cos theta. That means mg sin theta should be greater than or equal to mu mg cos theta. The other way. Now when you cancel out m, tan theta will be greater than mu or equal to mu. When tan theta is equal to mu, that is called angle of repose. This is the angle of the incline at which the body will start sliding down. This is the angle of the incline at which the body will start sliding down. When mg sin theta is equal to mu mg cos theta, tan theta will be equal to mu. It is a mere coincidence that this angle is the same as that of contact angle. Right? Others take it down. Dadar, listen to me. Angle of the incline at which m starts sliding. Dadar, were you people there with me when I calculated f minimum and f maximum to keep the block at rest?
Yes, sir.
Right. I dealt with only one small example after that. Take this down, I'll explain that. Listen, here you have calculated the angle of the incline at which m just starts slipping down. That will be mg sin theta will be greater than or equal to the limiting friction here. Then the body will start sliding down. So at what angle will it start sliding down? When mg sin theta is equal to mu mg cos theta. So tan theta should be equal to mu. That angle is called angle of repose.
सर बट जब वो mg sin theta mu mg cos theta का इक्वल होएगा तो रेस्ट पे होएगा ना तो स्लाइडिंग.
See that just starts sliding. He is as good as staying at rest. The next instant it will start sliding. That's why I put the condition greater than or equal to mu mg cos theta.
Sir.
Sir, 5 is greater than or if it is sliding, it will be always greater than the friction.
Just about to slide, mg sin theta will be equal to mu mg cos theta. The next instant it will start sliding down.
Yes, sir.
Now Dadar, once again pay attention here. I have taken one numerical example for them. Dadar, pay attention. If ever mg sin theta, others also will take it down. This is mu mg cos theta. If mg sin theta is greater than mu mg cos theta, then frictional force acting is mu mg cos theta. Yes or no? If mg sin theta is greater than mu mg cos theta, the body is sliding. When the body is sliding, what will be the frictional force? Mu mg cos theta. But if mg sin theta is lesser than mu mg cos theta, that means the body is not sliding. No, friction will be mg sin theta. Whatever is the external force acting on it, that will be the value of friction. Is this clear? Dadar, is this clear?
Yes.
This is what I have done for them when you people were disconnected. I just gave numbers, that's the only difference. Take it down.
So I couldn't quite get that part that when mg sin theta is less than u mg cos theta, that time f is equal to mg sin theta. So
Now the
could you just go
block
through
will
that
not
again
move.
once?
If mg sin theta is less than the limiting value, then the block will not move. If the
Yes,
block
sir.
is not moving, what is the external force on it? Mg sin theta. Frictional force will
Yes,
be
sir.
equal to mg sin theta.
Okay,
If
got
by
it.
chance whole of mu n is acting, then the block will start moving up. Which doesn't happen.
Yes. Okay.
Pulling a body. Suppose I am pulling at an angle theta. So it will have f cos theta and f sin theta. Agreed? When will the body move? If f cos theta is greater than or equal to mu n. Let me take the limiting value. F cos theta is equal to mu. What is the value of n? mg minus f sin theta. Agreed? F into cos theta plus mu sin theta is equal to mu mg. F is equal to mu mg upon cos theta plus mu sin theta. This is the force I should apply for the body to be pulled. Suppose I want to push at the same angle. Pushing. I want to push the body at the same angle theta. If this is F, this will be F mg plus F normal force mu n. F cos theta should be equal to mu n mu mg plus mu F sin theta. So F is equal to mu mg upon cos theta minus mu sin theta. To push a body, I need to apply this force. To pull a body, I need to apply this force. Which force do you think is lesser? Pulling a body is much easier than pushing a body at the same angle. That's why for a luggage trolley always you will be given a pulling option, not a pushing option. Then a person sitting in a wheelchair, why do you push? Why don't you pull? Because person sitting in a wheelchair, the comfort of the person sitting should be taken into consideration, not your comfort. Right? They are somewhere behind you and you are pulling, you don't know what is happening to them is not permitted. Hence they always make sure that wheelchair mein the person is sitting It is not easier to push, hence they bend the wheelchair and then they will make it move. Pushing will never be easier when compared to pulling. Above all, 1 second, listen. Now that from this I understand that pulling is easier. Pulling and pushing may I understand pulling is easier. At what angle should I pull so that the force is minimum? Find theta for which pulling force is minimum. Find theta for which pulling force is minimum. Please observe this carefully. You want this force to be minimum. That means the denominator should be maximum. Let me call the denominator as some function y cos theta plus mu sin theta. Right? dy by d theta should be 0 for y to be maximum. That will be differentiation of cos theta. Differentiation of sin theta. Equate it to 0. Tan theta is equal to mu is the angle at which I should pull for the force applied to be. What is that minimum force? Once I know tan theta, can I substitute sin theta, cos theta? Find the minimum force. F minimum. I am running short of space on the board. Not a big deal. Once you know tan theta, you will know sin and cos. Substitute those values here. You will get the minimum force with which I can pull a body. Lightning speed. People who have a doubt in calculating sin theta, cos theta from tan theta, you will have free access to our foundation builder classes. Rejoin them on Sunday. We will also advertise that our foundation builder students also clear JEE. Right? Anybody who has a doubt in calculating sin theta, cos theta from tan theta, Sunday afternoon 2 o'clock.
Sir, in F pulling and F pushing, sir, the maximum value of...
Speak.
Sir, in while pulling and pushing, sir, while finding the force,
Speak.
Sir, while pulling and pushing, sir, the denominator of F is has the same maximum value, no, sir?
No.
Sir, 1 under root 1 plus mu square.
So,
sir, so that means what is the exact difference then? Because the numerator is remaining constant, sir.
क्या पूछ रहे हो यार? यहाँ माइनस है, यहाँ प्लस है.
Sir, but you are asking for a maximum value for F to be minimum.
Obviously, the denominator is lesser, so pushing force will be greater than pulling force. Pulling force, this force will be lesser than this. Now, among lesser
Yes,
option, I found out the angle at which I should pull for the force to be further minimum. For sure, this will be lesser than this. From this, what is the angle at which I should pull so that the force is minimum? There are 3 places.
Sir, you found tan theta mu.
Pardon?
Yes, sir. For that you found tan theta is mu.
Right. Now tan theta equal to mu. Today's class we came across 3 places. 1. Contact angle. 2. Angle of repose. What is angle of repose? The angle of the incline at which the body will just start sliding. 3. The angle at which I should pull a body so that the force I apply is minimum. It is a mere coincidence that all 3 are the same. Nothing has got, no one tan theta has got to do something with the other. They are not related. Then find out F minimum. Please calculate sin and cos from here. Substitute here. Verify what is the minimum force. Today we just defined friction. Next class we will go ahead with the complications in it. Right?